Okay, just a preliminary. People didn't do well on this quiz, even though they did well in the homework, but they were doing identical problems. Okay? And I'm still trying to figure out how that happened. My best advice for you right now, yeah, I mean, you're going doing the problems is to prepare yourself so you can pass a quiz where they ask you to do this, where I ask you to do the same thing. Okay? So my best advice is, whatever you're doing to do the problem, go ahead and do it. Then put them aside and work them again the next day. And see if you know, work them again without looking at any notes, without anything, because you're going to have to come in here and do it without notes. You're going to have to do it pre-calculus class without notes. Okay? Makes sense? You're going to have to pass tests. So if you come into this class having made 90% of your homework and can't do any of this stuff, there's something that you need to do differently. And the thing that I think might, I don't know, I don't have a magic bullet, but the thing that I think might work best for most of you, if you're having problems, some people did quite well in the quiz, but most people didn't. Again, work with problems without looking at anything. Work them once any way you can, work them again without looking at anything, just using your own knowledge. Okay? Okay. Quickly, if B is 6, well, let's just do this. We're going to do this. Domain of the square root of 5x plus 8 have to do the square root of something. It's got to be greater than or equal to 0. So you just write down 5x plus 8 is greater than or equal to 0. Okay? Then you do a little algebra. Written poorly, but so we subtract 8 from both sides and do that with an inequality. It's kind of small down here at the bottom, but hopefully you can see it. So 5x is greater than or equal to negative 8. So you divide both sides by 5. 5x divided by 5 is greater than or equal to negative 8 divided by 5. And remember, if there was a negative quantity in front of x, you'd be dividing by a negative quantity, and that would reverse your inequality. Now that's all algebra 1 stuff. We're getting into a little algebra. And of course, math 60 is where you learn intermediate algebra. Okay? If your algebra is not up to this course, you might consider that MBE 60. Still possible to get into that. But anyhow, so you get 5x over 5 greater than or equal to this. Okay, so x is greater than or equal to 8/5. The first thing is you have to understand anything under square root has to be greater than or equal to 0. Any x that doesn't make it greater than or equal to 0 is not in the domain. So you write down whatever's under the square root has to be greater than or equal to 0, and then you do a little bit of algebra. Okay, you solve for x. That's what you do if you see a square root and you need to do domain. Okay. Now, for this one, Domain of x plus 5 over the quantity x minus 8 times x plus 11, let's say, if those were my numbers. What's the restriction in the domain here? Your denominator can't be 0. So x minus 8 and x plus 11 equals 0 is forbidden. I'm not going to write out the rest. Look back videos from earlier, okay? But I'll just say it. This is 0 as long as if x minus 8 is 0, right? So you say, well, x minus 8 is 0, you solve that for x, you get x equals 8, right? Now you can just see it here. If x is 8, that's 0. Okay. Here, if x is negative 11, it's 0. So your domain will not include negative 8, will not include 8 or negative 11. Okay. Now, if you lock that in, well, I think if you haven't already encountered that in your pre-calculus course, then you have the assignment in my pre-calculus course. If you're in the evening pre-calculus course, you probably have this for homework. Okay. And if you didn't, you're going to real soon. Well, there we have it. Okay, these composites, f of g of x is f of, you do the straightforward substitution. G of x is x. Sorry, x is now g of x. So you take this expression. Whatever x is, it gets cubed. If x is now g of x, then g of x gets cubed. That equals the cube of 1 over x squared, which is 1 over x to the 6th. And I'm not going to go through the rule where you get that because that's your assignment for, I think, like tomorrow or something, okay? Exponents, which is a big hang up for pre-calculus students, okay? So don't worry if you don't know that the cube of this equals 1 over x to the 6th. But if you can't get to here correctly, then you need to get just a little better at it. Okay? Now, you're probably going to be able to do that in your pre-calculus class because you haven't gotten to this in pre-calculus. Okay? You will very soon. So this is kind of a heads up for the pre-calculus, but also if you know what to do here, you're going to do it better in your pre-calculus class. Okay? So there it is. Now there's another way to write this out. So let me write it out. You could also have written f of g of x equals f of 1 over x squared. Here we're substituting g of x for x, because that's clearly valid, okay? And here we're going to just put in the g of x. We're just going to substitute 1 over x squared for g of x for the first step. And then we're going to see that we replace, you got to look at the rule for f of x. We're going to replace x with 1 over x squared with this rule. So that's 1 over x squared cubed, same thing we got before. And then if you know your laws of exponents, you know that this is 1 over x to the 6th. I think I saw 1 or 2 that got 1 over x to the 5th. And I'm not worried about that. If you have done the assignment on exponents and still think that's x to the 5th, then that's a little bit of a problem because you really have to have that, okay? You really can't let the algebra mess you up in your pre-calculus class and possibly help them. Okay. Okay, well, that's that. Now, there are a couple of other learning things that happen in pre-calculus early in the course. And composite functions, of course, is one of them, which is why we try to stress composite functions. And most of you are kind of getting there on this. I'm a little concerned that people didn't do well on this. Okay. And I'd like to see people do better on this one than they did. But listen, you're kind of moving in the right direction on that. If you aren't, well, start moving in the right direction. Okay. Okay. So since I'm on this, I'll talk about inverse functions. I want to talk mostly about inverse functions and transformations. Transformations is a big deal. I've got students in the most advanced courses we teach that aren't able to apply transformations. Okay, it's a hard thing for people to get. So a lot of times it gets left out of the course, even though it's a key idea in your course. We don't want that to happen. So we'll talk about transformations. But first, I'm going to talk about inverse functions. So let's try this. F of x equals x squared, g of x equals square root of x. Can you write out what f of g of x is? And what g of f of x is? Okay, so now most of you are just writing down answers or missing steps. I don't want you to miss steps. I want to see every step. Otherwise, as I said, I get nervous. Who knows what? Okay, I don't want to get nervous. Well, your goal is not to not make me nervous. I get nervous, I get nervous. It's not your problem. But really, you want to do it so that you can succeed in your pre-calculus course. So f of g of x, f of x is x squared, right? I have to replace x with the expression g of x because that's what's in parentheses now. So I've got this expression, but with this here instead of x, meaning I have to have this expression, but with this instead of x. So that is g of x squared, right? Now, of course, g of x is the square root of x. And if you understand what a square root is, it's a number that you square to get that thing under the square root. So the square root of x squared is just x. That way, you know, if x is 25, what's the square root of 25? Show me with your fingers. You have enough fingers to do that? Yeah, 5, right? And if you square that, what do you get? You get 25. So the square root of 25, if x is 25, the square root of 25 is 5, and you square that, you get 25, right? Which is x. Then g of f of x You can write that out as the square root of, because x is being replaced by f of x. Well, x is under the square root sign, so now f of x is going to have to go there. And what's the square root of x squared? Think about it. If you square 5, what do you get? If you take the square root of that, what do you get? You get 5, right? Square 5, take the square root. Square 5, you get 25. You take the square root, you're back to 5. That's how inverse functions work. Provide x is greater than or equal to 0. Square root of x squared is x. I'll just mention it. If x was negative 5, you'd square it and you get 25, right? And take the square root of that, you get 5, not negative 5. You wouldn't get back to your original number. So if you understand that, it's worth understanding. You're going to encounter it again. So I got to say, we got to restrict this to x greater than or equal to 0. There's a lot more around that idea, but I want to mention that idea right now. Okay. So, okay, now, the way I present inverse functions is like so. You got x here and y here. Let's say it's your 2 to the x function. We know that we're not going to use negative 1/2 and 1/2 because we can't do 2 to the 1/2 or 2 to the negative 1/2 except by approximation. And you don't even know how the approximation is made. Okay? You need to know calculus to know how the approximation is made. So you don't know calculus, you're not going to know how to calculate that, so we're not going to mess with it. We're just going to accept there is a value. We're not going to use it. Okay, so we're going to get 1/4, 1/2, 1, 2, and 4. So this is your y equals f of x. F of x is the x. Now from this, we can get a table for f inverse of x, for the inverse of x. And it's the simplest thing in the world. The inverse, you just reverse this column. Okay? So that your -2, -1, 0, 1, 2 goes here. 1/4 goes here. 1/2 goes here. 1 goes here. 2 goes here. And 4 goes here. Okay? So x becomes y and y becomes x. Understand that my x's became my y's and my y's became my x's, right? And now, this was getting all messed up. If I graph these, just using standard values, you should have graphed a number of times by now. Our f of x function has a graph that goes through these points and has this shape. Our f inverse of x function we're going to scale it like this, because now the values here go from 1/4 up to 4, don't they? Okay, the values of x go from 1/4 to 4. So when x is 1/4, y is -2. Now we have 1/4 here, we have -2 here. When x is 1/2, y is -1. When x is 1, y is 0. When x is 2, y is 1. When x is 4, y is 2. Okay? Now, I can sketch a curve through these points. Does this curve look like maybe it came from this curve? Well, I switched my x and y values. Okay? And if you look at it, you see that, well, that's exactly what it better look like. Okay? Now, there's more you'll read it in your textbook, in here or in pre-calculus. But you understand when we reverse the x and y coordinates, we get a new function. And we call that function f inverse of x. So here is the graph of f inverse of x. Now, you don't know what you're going to need to know later in the course, you know, around some late March, early April, how to write this inverse function. You don't know how to write out the rule for the inverse function. You do know how to get a reasonable graph, but you don't know how to do the algebra to get an expression for the inverse function. However, a lot of things you do. So let's just illustrate this. Let's see the whole board here. Y equals f of x equals x plus 7. Okay. So y equals x plus 7 for the inverse function. We just do what we did over there, but we do it with the symbols. We switch x and y. Okay. As we did over here with the table, we switched x and y. You get then x equals y plus 7. Now we solve for y. We subtract 7 from both sides. That will get rid of this 7, right? And we get 7 minus 7 is 0, so we end up with 1. So we switched x and y, so this is now the inverse function. So y is f inverse of x equals x minus 7. Right here, we have our formula for the inverse function. Let's test and see if it's an inverse. Okay, f of x is x plus 7, right? So what's f of f inverse of x? We replace this x with f inverse of x. So this is Okay, first step, replace X with F inverse of X. I hope you're getting used to this. Now what's F inverse of X? I thought it was X minus 7. What's X minus 7 plus 7? That's equal to X. So F of F inverse of X equals X. That's the test for an inverse function. Okay? Need to get that. Don't make me keep my mind distracted. Okay? Okay. Then, of course, we could say that, well, F inverse of F of X equals, well, now we're going to plug F of X into the formula for F inverse, right? Because here's F inverse of F of X. Here's our rule for F inverse of X. Whatever's in parentheses goes here. And that means that F inverse of X is F inverse of F of X is F of X minus 7. Well, F of X is X plus 7. And that equals X. So I'll put a check mark there. That check mark indicates we verified that F of F inverse of X equals X. Okay. Now, I'm going to lay just a little more algebra on you. Not always this way. Oh, come on. Can't do that. And y equals F of X equals 1 over X plus 7. You switch X and Y. You get X equals 1 over Y plus 7. We solve for Y. If you have a denominator in an equation, and make a note of this. I'm saying if you have a denominator in an equation, you multiply everything in the equation by that denominator. Okay? And that has the advantage that the denominators go away. You end up with an equation that doesn't have that denominator. Watch what happens. And y plus 7 is the denominator. Y plus 7 times X equals 1 over Y plus 7. Multiplied by Y plus 7. And let me rewrite this. I'm going to rewrite the left-hand side. The right-hand side is going to stay the way it is. It'll just be a little easier for you to look at. shouldn't make a difference. Instead of y plus 7 times x, I want to write it as x times y plus 7. Okay. It'd be okay either way. If I extra step, if I do it that way, do it the other way. Okay. Well, x times y plus 7 is what? X times y plus x times 7. Now, x times 7 is the same thing as 7x. Okay. And I'm going to write this down in some detail. I'm going to write, this is a fraction, so I'm going to write y plus 7 as a fraction, y plus 7 over 1. So if I multiply these out, I have y plus 7 over y plus 7. And any number divided, or any quantity divided by itself is 1. Well, now, what am I going to do about this? I want to solve this for y, right? Okay, well, if I subtract 7x from both sides, I'll get rid of this 7x, right? And I get it closer to having y, so I can say, well, okay, x y plus 7x minus 7x should then equal 1 minus 7x. Subtract 7x from both sides. 7x goes away. So fy equals 1 minus 7x. How am I going to solve for y? I divide both sides by x. It's xy divided by x. Okay. If you divide xy by x, you end up with y. Now, if this algebra is totally obscure to you, totally confusing, I have to tell you that your algebra might not be up to pre-calculus. Okay? And I'm going to advise you to start taking a good look at the videos I do for the MDE 60 course. They're posted on your Canvas page. The MDE 60 and the MDE 61 videos are posted. I'm not going to teach you intermediate algebra. I'm not, well, this is not even intermediate algebra. This is elementary algebra. Okay? And you need to know intermediate algebra to do pre-calculus. Okay? So I can't take the time to teach you this algebra. If you take the time to teach you this algebra, you're going to be missing some other stuff. Okay? I can tell you that in the MDE 60 course, we're just getting into the algebra solving equations. Okay? And you can see it more systematically there. You can also, go to Khan Academy, go to whatever online resource, but you have to learn to solve equations. And my experience is most pre-calculus students are clueless if they're confronted by an equation like this, we solve for what? Okay? If you're not clueless, then you're ahead of the curve. But you got to get to where you really understand these steps. Okay? I'm just following the rules. All I'm doing is adding, subtracting, same thing from both sides, multiplying, dividing, same thing from both sides, right? That's all I did in every step. Here, I multiplied by the y plus 7 using a rule that I advise you to lock into your brain because very few people have it locked in. Okay. Denominators are a pain in the behind, so get rid of them. Okay? In an equation, you can always do that. You don't have to deal with fractional expressions. Gotta be a little bit careful, and I'm not going into all the details of what you gotta be careful about, but that's what you gotta do. Okay? So I just multiplied both sides by y plus 7, simplified that. That step ought to be pretty easy to understand. Make sure we blow it here and write it as fractions so that we get this. So we get this. That all comes from just multiplying both sides by y plus 7. And doesn't this equation look a lot nicer than this one? If you're trying to solve for y, everything's in the numerator. Then we subtract the 7x from both sides. We're trying to get y. So we want to get rid of that. We don't get rid of it just by getting rid of it. We don't get rid of it by picking it up and moving it to the other side. We get rid of it by an algebra operation, subtracting 7x from both sides. And we have an equation that's really easy to solve for y, just divide by x, right? There's nothing hard about any of these steps, but when you start here, seeing what you have to do with all these steps, if you haven't done a whole lot of algebra, or if it's been 100 years since you did any algebra, that can be challenging, okay? Okay, well, I'll generally write out the algebra steps, but I'm not going to be able to take a huge amount of class time to teach simple algebra. And this really is simple algebra. Whether it seems simple or not, they'll be insulted because I call it simple. But it needs to be simple when you contain it in pre-calculus, so you don't get all confused about what you're doing. Okay, well, so f inverse of x is 1 minus 7x over x. Okay? And you can verify that. I was going to take the time to do that. Okay. Partly because the algebra of doing this is a little tougher than the algebra solving the equation. And I don't want to confuse you with the algebra right now. Okay? I'm going to give you the picture. Okay. Well, that's one thing. Now another big deal. You start with the basic functions. 5 functions. Y equals x squared, y equals 2 to the x. Okay. Y equals 1 over x, y equals 1 over x squared, and y equals x cubed. Just from those functions and things that follow obviously from those functions, along with composite functions, and adding and subtracting functions and multiplying and dividing functions, which is pretty easy. I mean, it gets messy, but it's easy to understand. You get practically all the functions you're going to have to deal with in your life. Okay? Functions model almost everything in the courses you're going to be taking, which is why the basic function picture is so important. I really stress that in my class more than I'm going to stress it in here because I don't know Ms. Gardner to stress it about it. I will be talking about the picture. And there's one more thing, it's transformations, to transform these functions. So let's take y equals x squared. What point goes on the graph if x equals 3?
9.
If x equals 3, then clearly y equals 9, right? Okay, so good answer, but doesn't quite answer the question of what point is on the graph. So what's the point on the graph? Just, it's got 2 coordinates, right? What's the first coordinate? You show me with the fingers. Again, the fingers in your hands. Okay. The x coordinate is 3, right? The y coordinate is, oh, there you got it, 9. Okay. Am I being a little loud? But not necessarily want to discourage enthusiasm. I'll just hold on to it. Okay. Point on the graph where x equals 3 is 3, 9, right? So we can my scale isn't real good, but here's the point. 3, 9. Okay, what's the point on the graph of y equals x squared plus 4 when x equals 3? Don't say it. Just figure it out. Easy, you just plug x equals 3 in here, what do you get? Okay. You don't have enough fingers. And once you take your shoes off, hard to hold up a right number of toes anyway. It's hard to hold. Okay, so, well, clearly, the point is 312. Right? So 312 ought to go about here. Okay. Now, how does the position of this point compare to the position of this point? And it's not 12. I said x squared plus 4 is 13. Y'all are looking at me like I'm nuts. That's not it. Okay. Okay, 313. Okay. So that point is 4 units higher. Right? I'll draw a little arrow here and put a 4 next to it. And you get a little crowded, but it's indicating that this thing is going 4 units higher. Okay. Well, it's not hard to see that whatever x is, if I calculate this, it's going to be 4 more than this, right? Which means every point on this graph shifted 4 units higher is going to give you a point on this graph, right? Now, don't have time to do this in as much detail as I'd like, but here's your graph of y equals x squared. Where's your graph of y equals x squared plus 4? Well, it's 4 units higher. Every point is 4 units high. So if I use arrows of the same length I have here, I get a bunch of points on the graph of y equals x squared plus 4. Okay. Now, if we have y equals 2x, what's your point for x equals 3? Oh, sorry, 2x squared. Well, if x is 3, you're going to square 3 and multiply it by 2, giving you 18, right? Okay, so let's see, where is 318? If 39 is here, how am I going to get 318? I'm going to have to go up that far again, right? I'm going to have to go twice as far up because that's well, twice as big, right? So this has to go twice as far. So I'm going to kind of draw it like this. This point goes all the way up. Make sense? If x equals 2, or x equals 1, well, right now, it's pretty well given. Anyhow, do that there somewhere. I still can't get it right. I'm hard to look at it on the chart. But anyhow, if x equals 2, then on the y equals x squared graph, you're going to get 4 units, right? So where's 4 units? Well, 9 is here. 4 is a little less than half of 9. 4 is half of 8, right? So you go down about half that high, and you come down a little more. And you got the point. 2, 4. Well, you do the 2x squared for x equals 3. You've got to go up to 8, right? How far up is 8? Well, it's twice as far as 4, right? So you can kind of indicate what you do this way and this way. And you've got the point 2, 8. And blue is on the graph of the 2x squared, right? You got this point and this point. And then, without writing it out, you got the point 1, 1, you go up twice that high, you got the point 1, 2. Now, if x is 0, you're going to get y equals 0 both ways, right? So what's happening? You go up twice as far each time, which means unlike this one, where you move the same distance every time, on this one, you're going to have to move further every time because the value of x squared gets bigger and you're always doubling it. Okay? And you're going to do the same thing on the other side. And you're going to have like negative 318. That's going to give you a graph. And it looks like this, where the x squared graph would look like this. I didn't draw that very well. You see pictures in your book. Okay. So this is an introduction to transformations. Now there are 2 other transformations. Let's just start with these 2. There's one that's a little bit confusing. I'll tell you. Yeah, I don't do that for 30 seconds. Y equals x minus 5 squared. That's going to move the graph. You would think 5 units this way because of the minus, but it's 5 units that way. Okay. So it's a little hard to understand why that is. I'll explain it to you next time. Okay. But that's the rule. You're going to see those rules. So your homework is going to involve I got the wrong course here. Be sure. They got to do inverse functions. Then you have laws of exponents, proportionality and variation, which I'll let you, it's pretty easy. Might have some trouble with it. We'll talk about it Tuesday. And then the equation of a straight line, the y equals mx plus b thing that you should already know. Okay, those 4 things. But the 2 toughest ones are the inverse functions and the transformation. Okay. And actually, that was due today. But we'll move along with that. After that, the course gets settles down a little bit because at that point we're kind of ahead of the curve in 161, and then we don't have to have quite as many assignments in a week. So I told you you're going to have to work hard for a couple of weeks. So starting next week, the assignments get a little less. Okay, but you're ahead of the curve. Hopefully, you have what you need. Remember what I said about put your work away and rework your problems, so you're prepared to do them when you come in here. Okay, very good. Let me stop the recording. Everybody walks in front of the camera.